So this is it. It's chapter 2 of Cisco 1. So we close up for today, and the most amazing chapter of the entire course is literally right here. We're going to do live config. Configure a network operating system. So with this, we have the PowerPoint up. We'll walk through it. At the same time, we're going to be using live equipment, which is the NetLab environment. So go ahead and wherever you are, whether you're live with me now or watching the recording, click Scheduler after you've already logged into the NetLab environment. And in Scheduler, you'll pick the class you're in, which is us, Cisco 1 Training. And you get a whole list of labs. For today, you're going to click on this lab. It's the third one on the list. It's called Configuring a Switch Management Address. This is the last lab of the Chapter 2 labs for this course. This is one of the ones that is your technical homework lab assignment anyways in the class. So go ahead and click on 2, 3, 3, 4. When you click on it, you get to see all of the pods. Every pod is the same as every other pod. It doesn't matter which one you click on. Just make sure you click on one that's not in use. The red line is the right now line. So click right below the red line on any pod, just not the one I'm clicking on. I'll take pod 10. And when you click it, it says, hooray, your lab will start now. And it's going to end at 3 o'clock or whatever time you're looking at, which is an hour away. For lab sakes, for the sake of the lab, give yourself until like 2 hours from now at least. I'm going to say end at 4 o'clock. That's almost 2 hours. Because you can never extend a lab. But you can always end early, but you can never ask for more time after the lab is scheduled. It'll just shut down on you when it's done. Also, that radio button, load default config for exercise, always make sure it's checked. That tells our NetLab lab how to load. Once I click OK, starting right now, my pod or rack of Cisco equipment with 3 2911 routers, 2 3560 switches, and 1 2960 switch are literally powering on as we speak right now, which is cool. And as you schedule yours, your labs will be popping up too, which is pretty darn awesome. So while you're doing that and scheduling your lab, we're going to get started. I'm literally logging out of my account and logging back in, not for just causing problems, but because I'm going to be able to see everybody's lab that's scheduled with me right now, and I'd be able to hop into their equipment with them live and assist, which is pretty cool. So while that's running in the background and your lab is loading, it'll take 5 to 10 minutes for the physical equipment to boot up to get the configs. So now I can see everybody that's scheduled their lab, which is great, and I'd be able to hop into your rack of equipment with you and watch you work on it live, or I can take over and assist, which is great. So we'll do that in a little bit. But for now, though, this is what we're going to talk about in our chapter. The first section is just about the Cisco Internetworking Operating System, and the last two sections are actually in the configuration of it, where we set up what is called our basic config. And the basic config is going to include password authentication. It's going to include a legal banner message to warn people away who shouldn't be touching your equipment. It's also going to include things like the name on your device. It will even include things like remote connectivity, deploying Telnet, which is our remote access of a device. Yes, even though Telnet's unsecure, not encrypted, we still teach you how to set it up because it's the basics for then deploying things like SSH with remote secure connections. Lastly, we do some basic IPv4 address configuration. I don't teach you subnetting here. I don't teach you the subnet mask. That's coming into play in Chapter 6 and Chapter 7 and Chapter 8. Here we're just going to talk about getting a reachable connection by addressing our network device. So without further ado, small little lecture window because we're just going to talk about a couple items and then we're going to demo on the left side in just a little bit. So we have what's called a Cisco IOS, Internetworking Operating System. And whenever we say iOS, according to law, according to Apple, Apple filed a lawsuit where iOS, if you just say it, it means the Apple operating system. And if you say Cisco, then you must say Cisco iOS. You can't just say iOS for Cisco. It is legit. There was a lawsuit filed. So we have the Cisco iOS. Thank you very much, so Apple. And with our Cisco Internet Working Operating System, what we're actually going to have here is a GUI and command line environment. By default, Cisco runs CLI, which is command line, typing in commands on a black screen, or whatever color screen you make it. But then we have the GUI, which is the graphical user interface, which Cisco does not actually have to have. A lot of the Cisco GUI environments we see with our routers and our switches is really limited. The graphical user interface is visual programming on top of our command line. The command line is still considered more powerful in Cisco than the software front end that we may see a graphical user environment where we can click and have a drop-down menu. That type of stuff, we use it more so in CCNA security. In CCNA security, we actually use a software device manager known as an SDM. We've also seen something called the CCP, which is going away, Cisco Configuration Professional, which are front-end GUIs. But again, they're limited. They can't do everything that a command line can do. But we need an operating system because without an operating system, all we have is hardware. And what good will hardware do for you if you can't control it or configure it? Just like hardware of a computer. So we then talk about an operating system. And the operating system gives us a feature set. It gives us the ability to interact with said hardware. But in order to do this, we usually have three terms. We have the hardware. The hardware is the physical computer itself, the motherboard, the NIC card, the actual physical components. And then we have the kernel. And the kernel, the easiest way to talk about it is like a driver. It's like you download drivers so your graphics card runs appropriately. You download drivers so your monitor is actually going to be able to scale to the correct resolution. Because without drivers or the kernel, we don't actually have successful communication when it controls how we talk back and forth between us and our electronics. And what then utilizes that kernel and those drivers is in the shell. And the shell is the interface that us, the users, interact with and can make changes on, which then talks through the kernel down to the hardware itself. Which makes sense. Shell's like your GUI environment, talking down through the kernel, which includes the drivers and which talks to the hardware, then the hardware itself. So onwards to these Cisco devices and how we're going to access them and to configure them. We commonly use something called console. And console is the first method you use to talk with a Cisco device. By default, our Cisco routers and switches are not running Telnet or SSH. By default, you don't remotely access these. By default, you have to physically plug in your device on a blue console cable, they're usually blue, and the console port of your Cisco device is usually blue. And then from there, we have a physical direct connection from our PC to the router or the switch. The port on your PC is commonly known as a serial port. There's multiple designations for it, but the common one we see uses an RS-232 connector. RS-232. You'll even see it in Packet Tracer. That you plug a console cable into your RS-232 port, then you plug it into the console port on a Cisco device. If a console port cannot be reached or is unplugged, there's another port we commonly see on Cisco routers known as the aux port. The aux port is commonly utilized with a backup dial-up connection, not to move data from the router across a network, but a backup dial-up connection so when all else fails, you can dial into the aux port on your router and try to control your box. Lastly, on these same cables and ports, you move network data on your fast Ethernets, your gigabit ports, your fiber link, whatever it is. On the same ports you move your network data, we can also allow Telnet or SSH management traffic. And that's called the virtual terminal lines. We'll see these as VTY lines on our boxes that we configure today. Now to access the console port or the aux port or the VTY lines on our Cisco box that are virtual, we need some type of program or software to help us get there. So there's multiple different types of software. I prefer the one in the middle, known as Terraterm, but there's a lot of stuff. Putty is good too. That's cool. It depends on how much customization ability do you want. So we're not tested on the types of programs. You are tested on these three methods of access, though. You're tested on physical access using the console connector. You're tested on what is the difference between Telnet and SSH. You will be tested on that, but not on, hey, do you use Putty or Terraterm or Secure CRT? That's not part of anything because those are different products. So if we use Putty, which is a possibility, we can use the serial button on the far right side. And when you do that, you're using a console port, which would be your RS-232 connection from your machine to the console port of a Cisco box. If you wanted to use remote access, you'd have the Telnet button selected, which would change it to port 23, or SSH, which is port 22. For Telnet and SSH, you'd actually have to type in the IP address of the router or switch to remotely access it. But by default, you can't SSH or Telnet to anything because by default your Cisco box is not running that, so we'd have to use the serial connection, which is console. If you're using Terraterm, my personal favorite, I love this one, you have one whole box just for remote access, and a whole another box you could select if you have an RS-232 port for serial. Lastly, the one I have never used, Secure CRT. Can't even say a thing about it. Cool, looks like it has tabs though. That's kind of neat. So does Putty, and so does Terraterm. Now, I mentioned the console port. It is blue, but the neat thing is, as newer Cisco devices have come out in the last 2 years, we now have USB console too. Because how many people have a serial port on their computer? Not as many as you'd think. A lot of the new computers coming out in the last 5 years do not include a serial port because people used to use serial and parallel ports. They used them for things like scanners and printers. I see a parallel cable every day on my way to work. Somebody has it hanging in their bird feeder in their backyard. Not kidding you. It's the one with the purple connector on the end with a really thick gray wire. Yeah. So serial and parallel were around for a very long time, and they were usually meant for things like that, your peripheral devices. But now everything's USB. So we actually now see USB console. So that's a little USB console, the same type of connector you see for those older Android phones. And then look, that's the normal console connector here. Now, a lot of questions come in of, can you use both console ports at the same time to control the device? The answer is no. Once the USB console is live, as in plugged in, then this other one becomes disabled. You can't have two console sessions in the same box at the same moment. The course has a little video regarding the console port. So it's time to actually get into the config. We're going to start walking around. I'm going to teach you the different levels of config and how you can work through your device and what the different areas are going to be and how to go forward and backwards in terms of going deeper into the command line architecture and making your way all the way back. So before we go into basic device configuration, I have some walkthrough to do. So please click Enter Lab for you. If you've never clicked it yet, please click it now, Enter Lab, and you will get your lab environment. You have live physical switch. Switch 1 is a 3560. And you have a Windows 7 virtual machine. Go ahead and click on your switch 1, which is your S1, and just execute the Java file that's given to you. From here, you will get a live console connection on switch 1. Real device, not virtualized. Yeah, run the Java. Run as fast as you can. There we go. And now we have a live console connection. Just tap enter, and you're literally on switch 1 on the console. Again, it's not virtualized, it's not fake, it's not software. I'm going to increase my preferences font size for 16. There we go, that's better. And to show it to you, let's walk through a couple commands. We're on the physical switch here on the blue console port. Right now, we're like at what's called user mode. And user mode is like the default, most basic, lowest privileged mode you could ever be at. Well, how do we know? Well, in Cisco, there's something called context sensitive help. At any time, you can type question mark and you can see what commands are available. So with nothing typed in at all, we'll just hit question mark and we'll see all the options that are available to us. Because I increased my font size, I'm just going to increase my page a little bit. There we go, it's better. And we can actually see all the options we can do. So right now with user mode, which is the most basic mode we can be in, user mode is the greater sign. That's what depicts us as user mode. I can do some basic things like clear, connect, disable. There's no delete command here. There's no erase command. There's no reload command. I can't reload the box. It's kind of basic. A lot of the stuff is all about verification and basic connectivity. And this is what the interns should be allowed to do. The interns can be allowed to enable, the interns can be allowed to do a show or resume a connection. But there's nothing really here regarding managing the box. So in order to give ourselves more privileged access, to allow ourselves to enable us to be able to do more, we have the enable command. When you type enable, hit enter, and you'll watch your prompt change. When you type enable and hit enter, we go to what's called our privileged exec mode. Some people call it user exec, but I don't like that because it's too close to user mode, where user mode is the greater sign. Privileged exec mode is the pound sign. And now if you type question mark again to view your current commands capable, check that out. More. To go through more, you can do enter to go one by one, or spacebar to go section by section. And look at that, there's a lot. There is a total lot. Now we can scroll back up and read through this, but we see things like now setup. Ooh, that looks kind of cool. We see other things come into play such as write, where we can save a config. At the top, if we can see things now called erase, disable. We're able to do a lot more here now that we're in this privileged exec mode. So, oh look, there's a configure command. Configure, we can configure something. At this level right here, this is where we can do a lot of our saving our work, copying and moving a file, backing up our config that includes usernames and passwords. We can even set the clock here to set our time. We don't want any random person setting our time. We want to make sure that we actually have a legit person doing it because times go along with servers, and servers like to track things like a logging server or a security system and say, yeah, router 1 reported a break-in over a user account at what time and date. Well, if people mess with your clock, they're going to be sending incorrect timestamps. Not cool. So privilege exec mode gives us more power. And now we want to be able to configure something. I would like to go into an interface, actually put like an IP address on something. So the command to do that is to go deeper now, and is to access what we call global config mode. To get to global config mode, the command is configure terminal. With configure terminal, you click enter, and now your prompt changes again. Not just switch greater sign, which was user mode, not just switch pound sign, which is privilege exec, but now switch config pound sign. And now, of course, you do a question mark here, and we get to see all of our options. We can deploy access control lists. We can deploy AAA security, which includes authentication, authorization, and accounting. We can deploy alias commands, which are not covered in any of the Cisco classes. We use these in CCIE, kind of cool stuff. Make your own Cisco command, it's kind of what it is. We can do a lot of stuff with authentication. We can tell our Cisco router or switch how to boot. This is literally like changing BIOS commands here. Oh yeah, don't boot from the hard drive, boot from the CD drive, boot from the USB flash drive. Well, with Cisco routers and switches, a lot of them have USB ports. You can even tell a device to boot off of a TFTP server. So cool, it's like a remote network boot. You can do it. So that's here in the global configuration mode. We also can do more with clocks. We can even do a lot more here now with other protocols, including even things like spanning tree and loop redundancy. You can give yourself a name. We can go into interfaces on our switch and do specific interface commands of, hey, port 1 off. Just turn port 1 off. Shut it down. Turn it off. We're not using port 1. Physically turn off the port. We can do that by going into specific interface config as well. You're like, okay, I'm quitting Cisco. There's way too many commands. Don't worry about it. You learn the commands that you need to learn. There's no single person in the world that knows every single Cisco command. That's not the way Cisco works. In order to deploy technologies, we have different Cisco certification tracks. There's a Cisco voice track for voice study and voice configs, a Cisco security track for security studies, security configs. We even have a video track now, Cisco certification studies for video. Yes, because there's so many different types of Cisco commands, so many different types of Cisco products, there's no one person who will know it all. It's just the fact of, are you comfy enough to move around in the operating system and work your way through it, which is a yes. That's where we're going to get to. So here we are in global config mode, and now let's make our way to a port. We're on a switch here. Let's make our way to an interface, and that's interface. Well, how do I know which ones there are? Well, which is cool. If you type a word and space, after a space, you can hit question mark. Check it out. It says, oh, you use the word interface? Well, these are all the options that can come after the first word of interface. So interface async, interface ctunnel, interface fast Ethernet, interface port channel, loopback, virtual trunk. You're like, oh goodness, there's a lot. Interface gigabit. Again, we don't need to know all these. When you're done with Cisco 1, we'll be comfy with interface loopback. We'll be comfy with interface fast Ethernet, interface gigabit Ethernet, and interface, where are you, VLAN. We'll be comfy with those after Cisco 1. The other stuff, meh, we'll get to later, other courses. So here we are. Interface what? How about fast Ethernet 0/1? Well, how do you know 0/1? Well, the switch we're on is a 24 port switch. This 24 port switch has 24 fast Ethernet ports and 2 gigabit ports. The first port of any Cisco switch is always 0/1. Enter. And now our prompt will change. Configuration mode -if, which is now we're in a specific interface. The interface we're in is the one we specified above, 0/1. And here you can hit question mark again, and huge options all available for just configuring port FA 0/1, Fast Ethernet 0/1. Cool stuff. Inside of here, we can set up IP addresses. Inside of here, we can tell the port to be up or be down. We can turn on security on this port to track what MAC addresses are coming in here, and we can kick people off the wire who shouldn't be here. This is all because we are a managed switch. When you purchase a Dell switch or a Netgear switch or an HP switch that is considered unmanaged, all you can do is plug users in and hooray, they can talk on a network. When you purchase what is called a managed switch includes this: per port configuration, global switch configuration, and you can customize how your network actually flows, which is pretty cool. If you don't like the more prompt though, and you want to get out of this, you can just click any letter. I'll click J for Justin, and it bounces you out of the more prompt. Otherwise, whenever you do a command like question mark, you're like, okay, space bar, space bar, space bar, space bar, space bar, space bar. You're taking your time. Just type a letter and it will bounce you out. So that's cool. This is how we're going to move around. We've gone deeper and deeper, but now how do I go back? How do I get back to that global config mode? Well, the command is exit. Exit will take you back one level. Bump to global config mode. To get back to privilege exec mode, exit takes you back one level. Bump. And now we're here. To get back to user mode, you could try exit. Bunk. Takes you all the way out. There's another command though called disable. Disable would have taken us backwards too. But still, exit or disable. Cool shortcut though while we're here before we go into the basic device config. If you work your way deep, like enable, work your way deep. Configure terminal, deeper. Interface, fast Ethernet, 0/1. You can go all the way out with a shortcut command. And this shortcut command is one of your questions in one of the labs that you work on. Control C. If you do Control C, it'll bounce you all the way back to privilege exec mode from wherever you are, just using Control C. So try Control C as in cat, and it'll bounce you all the way back, which is cool because it helps you bounce around really quickly in the config. Also, you'll notice, what was that? How did I do that? When you have commands, like right now I'm in privilege exec mode. If I work my way deep again, configure terminal. If you have commands that are not going to be, let's just say, using the exact same word as another command. How do I explain this? Let me do interface space question mark. Hard to explain. Interface space question mark. With interface space question mark, it says, all right, everything that starts with interface is right here. Fast Ethernet is the only command that starts with FA. Because it's the only command that starts with FA, I can use a shortcut. Instead of me having to type out interface fast Ethernet for every single time I want to access a port, I can shortcut this command to just FA. I can do that because it's not going to be misunderstood as another command. Well, why don't you just do F? Because I can't, because there's another command that starts with F, filter and then filter group. So what I'm saying is I can say interface FA 0/1 instead of doing fast Ethernet 0/1. That's just wasting time. I can just say FA 0/1 because FA does not overlap with anything else. Cool? Also, interface. That command interface could just be INT because INT does not overlap with anything else. You can see it. I can do I with no space. Kind of crazy. I with no space, question mark. And it says, oh yeah, all the commands that start with I in global config mode here, every single command that starts with I is identity, interface, IP, IPC, ISIS. No, it's not political. That is a routing protocol. IXI. So I can say INT space FA 0/1 because INT is the only thing that means interface. There's no other INT command that starts with that. FA is the only command that starts with FA, which is corresponding to fast Ethernet. So I can shortcut to int FA01, which really means interface fast Ethernet. I can't spell Ethernet 0/1. Means the same thing. Now you're like, well, you don't need to do that, Justin. You have the tab key if you've read ahead. I can type in INT, and then I can't spell. Tab, and it auto fills in the rest of the word. Fast Ethernet, I can't spell. Fast tab fills in the rest of the word. But tab only works if you've typed an appropriate amount of characters that makes the command unique. For example, I can't tab on the F because there's an FI command that exists, or there's an FA that exists. So it can only autocomplete with the tab key if you have something unique already typed in. Why are we learning this? You can't shortcut on cert exams. You can't do that on a cert. You can't have it autofill on a cert. Yes, you can. The certification exams allow question marks. They allow tab. Works beautifully. I've been there, done that. So it does allow it. So anyways, I don't know where I was going anymore. Woo, off the record. So let's continue onwards. This is our environment. And we got to get comfy going in deeper to configs, backing our way out. Exit takes you back one level, as I mentioned. There's another command called end. End does the same thing as Control C. Bounces you all the way back to privileged exec mode. Control C and end, they're friends. They take you all the way back to privileged exec. So it's time for the basic device config. So here we are. We're going to tell our device to have a name. And a name isn't just a random label like, well, this doesn't matter. Let me name it Fluffy Kittens. You can't do that. Well, you could, but you don't want to do that because these names will actually be seen on the network. Our Cisco switches are going to talk to other switches. Our Cisco routers are going to talk to other Cisco routers and switches. We actually have protocols that talk between the devices and they'll share information between each other. And then we have things like, hey, look, there's a protocol called SNMP, Simple Network Management Protocol, SNMP. You can use this protocol to automatically pull info from your devices. You can even use protocols like this to automatically tell your device to configure itself with something. Well, device names are going to come in handy with that. So we want to configure our host name. To configure a host name, we're going to configure it. So let's head over to configure terminal. You're like, do we really have to type this out every time? No, you can shorten it because if you hit question mark after T, it says, oh yeah, T with no space and a question mark. The only command that starts with T after configure is terminal. So technically I can just say configure T. And it does the exact same thing as configure terminal because that's the only T command after configure. You can even shorten that to config T. Config T. And it does the same thing for the reasons of shortening. So here we are. So to configure a hostname, the command is hostname followed by one word. There can be 0 spaces. You can't have a string of words with spaces. If you want to have multiple words, we commonly recommend underscores like floor 1 underscore switch. You can do that. A lot of us like all caps though. All caps is cool. And now, once you click enter with hostname followed by what you want to name it, you'll see your prompt change. Now your device is noticed and understood as this. You can have the same host name on multiple boxes. It's not recommended, but you could. There's no error that's going to pop up. We'd always prefer that every device have its own unique name, though. So we want to configure passwords. Well, why do we want to configure passwords? Because anybody can right now plug in a console cable to this box and have full access to it. Huh. And we talked about how if we back up a little bit here, type exit, takes you back. We're in the privileged exec mode. We talked about how there was this user mode, which we can get to by exiting again or by typing disable. And this user mode, people can't do much here. But then in privileged exec mode, the next one, they can reboot your box, copy your config. You think there'd be some security there to lock between this user mode and privileged exec. And there is. It's actually called the enable password. Now, the enable password is configured in our global config mode. So we'll make our way there. Enable, enter. Oh yeah, sure, come on in. Now you're privileged. Config T. Yeah, sure, come on in. Now you can configure stuff. No passwords needed. And here in global config mode, we're actually going to utilize this mode to build a password. And the password we're building is going to lock down right here. When people type in enable in this greater sign, which is user mode, we're going to say, hey, before we give you privileged access, which is the pound sign, verify who you are for me, will you? That's what we're about to do. It's called the enable password. Now, there's an old version of this called the enable space password, followed by putting in a password here like Fluffy or Cisco or Super Secure. This is an old mechanism we do not use anymore. This password that we're about to create using enable password is stored in plain text. Anybody who gets access to your shoulder, aka shoulder surfing, and watching your screen, will see the password stored in your box in plain text. We don't want that. So the more secure version is actually called the enable secret. So we use the command enable secret followed by whatever we want the secret to be. In our case, we'll make it class. Enable secret class. And once you type in enter here, it says, oh, awesome. Now whenever people type the enable command, it's not going to be instant in welcome to privilege exec mode where you can modify our config and wipe our box and reboot it. But now it's going to say, hey, let me double check you. Who are you? Ask for a password. To see that, let's do it. Just hit Control C, tap it a couple times if you want, and then you're going to type disable, which takes you back out to your user mode, and we'll see if it works. Once you type enable in your greater sign mode, which is your user exec, or sorry, your user mode, gotta get that lingo. Once you type enable and hit enter, it says, who are you? And now you can't get through into the privilege exec mode unless you have the correct enable password, aka here, enable secret, because we're using the secure form. So that's just class. As you type it in, there's no error here in NetLabs. This is just the way Cisco boxes work. As you type in a password, it is not shown for shoulder surfing reasons. Type in class and hit enter, and now we're on the box. So we had this first mechanism of security of preventing the interns from gaining access to really configure and reload and reboot and lock down your box on you. We have the enable password coming into play. To view that the password was configured, inside of your privilege exec mode, this # mode, we have a command called show running-config. Show running-config is what we're going to do here. And this is awesome because this is going to show you your current configuration on your box. So I'm just going to boot up my font size just a little bit more. And it's show running-config. Enter. And this is going to give us the full configuration on this Cisco box. And right here at the top, it says, current configuration. It's 1.4K. That's it. Very small. It's just a text file. Don't worry about timestamps. This router was not built in 1993. I can tell you that for sure. We have the host name that we've configured. And look at this, enable secret 5. 5 means MD5 hashing. And here is the built hash of the word class. No shoulder surfing here, no plain text password being shown. We have an MD5 hash, which is the password of class here. Cool. If you wanted to, we can spacebar down through our entire config, see how every single port is configured. That's kind of cool. Yeah, nothing on those yet. And then at the end, we see line con 0. We're going to get to this in just a couple minutes where we're going to lock down our console port. And line VTY, what's that? That's the telnet and SSH lines, the virtual terminal lines that we're going to be able to lock down in order to have management or prevent management of our box remotely. We'll play with that a little bit later today. So let's continue onwards. As we go further then, we're going to lock down the console port and we're going to lock down the VTY lines and continue on. To lock down the console port, we got to get on line con 0. You can't just type it from privilege exec mode of line con 0, which con is short for console 0. You can't do that. It says, little mark there. There's an error at the I in line. We don't recognize that. Well, what do you mean? Well, if you type L question mark, it says you have lock, logging, login, log out. Line, that word does not exist in privilege exec mode. So we must go to global config, which is config T, which is short for configure terminal. Inside of here, now I can type in line con 0, which get me on the console line. And people say, well, how do you know it's 0? Because if you hit question mark, it tells you. For the console line, we have only one of them. You can either access line 0 or line 0, because there's just one console port. Henceforth, Cisco usually starts with 0 in their numbering. Once we do line con 0 and hit enter, now I'm on that blue console port right now on the box. And this is where I'm going to lock it down. To lock down the console port, we want a password. So we use the command password, followed by what we want it to be. Cisco is awesome. Why? Because it's an easy password. Password of Cisco. And now the hardest command of today, login. Login is a very interesting command. When you type login and hit enter, this is exactly what it does. Login enables password checking. Let's focus on this. Login, that command, enables password checking. What it means is you've just put a bouncer in front of the door saying, I'm here to check passwords. And the reason you're like, well, that's basic, Justin. Why are you making a big deal out of this? Because sometimes in certification exams, you'll see an output of commands, and in the output of commands, you see this, no login. People see this like, oh, no login. No login means no one can enter. No login means super secure. The doorway is closed. Well, in reality, it doesn't. No login means we remove the bouncer. No login means we've disabled password checking. Let me get on my soapbox. You can have a password of Cisco configured. You can have that right there. We do. And you can have no login, which means the password of Cisco would be the password checked. But by the way, we have no login configured, which means we're not checking passwords. So right now, open door on the console port. That's what no login means. We've disabled password checking. You could type in password Cisco 45 times, but because it's no login, it's not asking for a password. No login means no password checking, while login means check the password. Cool. So let's back up one level, exit, and now we're going to head into the VTY lines. The VTY lines are literally virtual connections that exist on the motherboard. You can have a 500 port switch. With a 500 physical port switch, you might have 16 VTY lines. Like, how shouldn't you have 500, one per port? No, the VTY lines exist on the motherboard. They're virtual connections that allow you to remotely manage the switch by remotely connecting to the motherboard. What that means is you can connect in through any of the 500 ports with Telnet or SSH and target the switch itself, the motherboard, and you connect on the motherboard. Kind of cool. So line VTY, well, how do I know what the lines are? They say 0 to 15 in the slide. Well, every box is different. After VTY, do a space question mark. It'll show you. This switch also has 16 lines, 0 through 15. Some of our routers have over 1100. Some routers have 181. Depends on the box. To target them all, I would say 0, the first, space, 15. And now I'm configuring all 16 remote connections possible for my switch. Enter. We're in config line mode, looks just like the console, but this time we're configuring 16 separate virtual connections. You could have 16 separate people all connected into this switch at once. That's what it means. 16 remote connections can be supported at one time. So let's lock it down. Password, Cisco, and then login, which enables password checking. Cool. Not too bad. Straightforward. Now we can exit out, which takes us back to global config mode, and we're going to go further in our config. The problem we have is when you use this password command puts the password in plain text. Just like the enable password command that we mentioned earlier, whenever you see the word password, that means plain text. So what I want to show you right now is if we exit back one more, we could then use our little status message. I'll teach you how to take that away later. Privileged exec mode, show running -config. You could also tab it because it's show run tab. Show running -config gives us our running config again. Type that and hit enter. Show running config and hit enter. And again, that's privileged exec mode. You cannot run this command in global config. You can't do it. It won't take it. You got to be in privileged exec mode. So inside of here, I'm just going to hit spacebar because the console and VTY lines, I'm going to keep hitting spacebar, are at the bottom. So spacebar, 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 spacebar. And now we see console 0, password has Cisco. Horrible for shoulder surfing. Login, password checking is enabled. It separates the VTY lines in two segments, 0 through 4 and 5 through 15, just for organization. Password Cisco, login. Password Cisco, login. So this is horrible again for shoulder surfing. You're working on your box, somebody's standing right at the end of your cubicle chatting it up at the water cooler. You're like, dude, not cool. So how do we password protect these, aka encryption? Well, there's a command. And the command is in global config mode. And this command is a service. Like, what do you mean service? Well, in your Windows box, let me just show you this. In your Windows box, if you opened your task manager, seriously, computer, if you opened your task manager, if you open your task manager, inside of your task manager, you'll actually be able to take a look at what's running in the background. Well, there's services running in the background, and these are things that you don't see up front. They're actually handling application and data behind the scenes on your box. Well, we have the same type of thing on a Windows box, In a Windows box, we have services. In a Cisco box, too, we'll have services. So we're actually going to activate a service that's going to run in the background on our switch, and it's going to encrypt any plain text password it finds. So let's do it. In global config mode, it's service. We want to activate a service. The service is password hyphen encryption. And if you can't spell like me, just hit tab and it will autocomplete password hyphen encryption. Once you hit enter, this is a certification exam item. Once you hit enter, the service is running 24/7. I don't have to activate this service every time I create another password. Some people think, oh, well, now if I create password fluffy, now I'll have to run the service again. No, it's a service that runs in the background just like a service in your Windows box. So anytime you create a new password, the service is always running. It's just going to encrypt as long as the service is running. Okay, so what's the difference? Well, if we do Control C or exit or end, whatever you do to get back to your privilege exec mode, we can run our show running config command again. And you can either type it or it's time to cheat. Cisco has a history. It's built off of Linux, and Linux has a history. And if you hit the up arrow, you can actually sort through your previous history commands. Commonly, Cisco memorizes about 7 commands, sometimes 10, depending on the box, and you can customize this, which we kind of don't teach you, using the history command. So I can just cycle through my up and down arrows and find the show running command and enter it. Hit enter. And if we scroll to the bottom using spacebar, check it out. Console and VTY, look at that. Now they're encrypted. Now this is Captain Crunch decoder ring. Literally, Captain Crunch decoder ring encryption, like that week. Because as you'll notice, hey look, the encrypted is the same as everything because they're all the word Cisco. And also I can highlight this and right click in NetLabs and copy it. And while I copy that little encrypted item there, I can go to Google and say, Google, I need your help. How about a Cisco password cracker? Let's find one. Cracker. Cisco password cracker. Oh, look, there's one. And what if we just take that password, put it in there, and say crack? Oh, there it is. Cisco. Moral of the story. Type 7 passwords are considered old, and they're not supposed to be used anymore. Wherever you see the word secret, we should use. Well, what do they mean type 7? Well, what they mean by type 7 is right here. When we use what's called a type 7 password encryption, it's like the weakest encryption you ever have with Cisco. It's not meant to NSA lock down your box. It's meant for shoulder surfing, where it'll be very difficult for Johnny at the water cooler to remember 070C285F4D06. It's not meant for encryption. It's meant for shoulder surfing. That's all. So well, how could we have made this better? Well, in later courses, I'll teach you how to actually deploy MD5 hashing or SHA-1 or SHA-256 with encryption. Just for now, this is basic. This is basic for shoulder surfing. All right, continuing. So as we're getting near the end of our config, we're about to go towards IP addressing and remote management. We're perfect on time here. There was a legal case that came about. A couple students at a university were playing around on the network. They're using some tools, and they found that some devices were responding on port 23, port 80, and port 443 and 22, which are all management style ports. So they connected to a device, and when they connected to a device, this is what they saw. And there we go. They saw this. They clicked enter, and there wasn't even a request for a password. They were live on the device. And we'll get back to this together in a second. They were live on the device right here. So they started playing around. And they started playing around, and look what we can do. There's a reload button. There's some config stuff here. We can delete, erase. And they messed around with it until eventually the device became unusable. Well, little did they know, or maybe they did, the device was a live network enterprise device. And they took down part of the network at the business lost money, you name it, things happened. Legal case came about. Company tried to sue said students slash people. Company lost. Company lost because there was never any single message that actually said you should not be here. There was no message that says this is not a lab device, this is not a testing device, this is not a student device. There's nothing that said that. So for legality purposes, we will be configuring banner messages on all of our devices. And a banner message is awesome. There's login banners. There's actually aux banners for auxiliary port. There's executive banner. There's a message of the day banner. There's all these different types. You don't need to learn them. What you need to learn is just one, called the MOTD banner, known as Message of the Day. The reason we teach this banner is because this banner will show everywhere. Any place that someone can access the box, this banner will show. So let's configure it. Global config mode, config T. Inside of here, the command is pretty easy. Banner space MOTD for message of the day. And now the hardest part of this entire chapter for configuration. If you hit space and hit question mark of what comes next, check out what you see. You see something that looks like it's Latin. C banner text C, where C is a delimiting character. In English, what this means is whatever character you type, like for me, a $sign, this will be my starting character. And when I'm done with my message, I'll type this character again, which is my ending character. Henceforth, we call it a delimiting character. It'll be the start and stop of your message. The people that view the message will not see this character. This character is just telling the router or switch, hey buddy, the crazy like A's, B's, and Z's you're about to see, I know you're not going to understand it because you're a machine, but whatever happens between $sign and $sign is the message. And that's what you're telling your box. So we do $sign, £sign, exclamation point, whatever you want. Just make sure you don't use this in your message. So I'll use $sign. Why not? And then I'll say authorized access only, exclamation point. Please consult with Justin Valentino before accessing box. And then you'll say, you will be fined, question mark, whatever you want. Fined, prosecuted, you can go with whatever you like. Prosecuted, there we go. And then you just end your message with what you started with. I started with a $sign, so I end with a $sign. And once I click enter, no errors. When you see no errors in Cisco, that means it worked. That's how they work in Cisco. So how do we see it? How do we make sure it worked? Well, we've done console passwords already. We've done enable secrets already, and now we have a banner. So we have a lot of things to test anyways. So what we're going to do is Control C or end or exit, whatever you like to take you back. And then the command is log out, one word. Control C, end, exit, whatever takes you back. That is such a weird thing, this monitor. I need to get a new one. And then you probably don't see the message. This is my monitor is about to turn off in 1 minute. But anyways, so log out, bounces your connection, and then it says, all right, hooray, this is like you just plugged in the console cable. You go to hit the enter key after plugging in the console cable. And look at that. Banner message, authorized access only. Please consult with Justin Valentino before accessing box. You will be prosecuted. That is your legal message right there. That's your safeguard saying you do not belong here. This is not an open environment thing for you. You can make this 3 paragraphs. You can make it 5 pages, whatever you like. And then because we have a console password configured, user access verification, it doesn't even give me user mode because the console password has come into play. I'm accessing it on the console port. It says, should you even be here on the console port? The console password was Cisco. You type it in and hit enter. Then it says, congrats, you've made it to the floor 1 switch, user mode. And then to get further in user mode, you got to remember the enable secret. And that enable secret was the password we set up to go from user mode to privileged exec, and that was the word class. You got to type enable first, enable, and then class. And now we have 2 levels of authentication. We have should you even be on the console port? Yes, the intern knows the password of Cisco. But then, hey intern, you can do some show commands, but you can erase, reload, delete my box. So then the intern would not have the enable password known as class. And now we're back in our box with all of our legality stuff coming into play. Now, interesting thing about Cisco and how it works is everything we're doing right now is stored in the running config. And that's that show running config command, which we can actually shorten down. I'll tell you to show run. You can use show run, which is short for running -config. And everything we're doing right now is in this running config. And the interesting thing about this running config is it's all in RAM. And just like a computer, a Cisco device that loses power or reboots or shuts down clears its RAM. So everything we're doing right now is stored in RAM, and if we had this box reboot on us right now, we would lose everything we've done. So we need to copy our config from this volatile place called RAM and save it in a not volatile place. And that's actually called NVRAM. NVRAM exists on your box. It's a piece of little hardware chip, memory chip, and this is where we want to copy our configs to. Because whenever your router or your switch boots up, it actually boots from the configuration stored in NVRAM. non-volatile RAM. Whenever your device boots up, it copies the config. It actually copies it from NVRAM, a storage location, and pastes it in RAM. So, moral of the story, you boot your router, the config is copied from NVRAM, loaded into RAM, and you're working in RAM. Oh, why is that cool? Because don't do this, just watch. If I did enable secret, blah, 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 enter. That's not my enable secret password. So if I ever wanted to go and type the enable command to go from user mode to privileged exec mode, that's what I have to get through. Well, how does this correspond to RAM and NVRAM? If I'm working on my box and I'm at a place where I feel comfy, everything looks good, it's all working, I would save my work at that location. But if I ever get to the point where I'm working on a box and I've just totally messed this thing up and things are starting to fall apart, the network's becoming unusable, well, what can I do? I can just reload my box. With a reload, it reboots my box. Whatever is currently in NVRAM is what is then copied into RAM and loaded up. If I only saved my configs at good points, the good config is loaded. For example, if I already had my work saved and I did this horribleness, well, hopefully I haven't saved it after I did this craziness, it would reboot with what I last saved, which is great. So you're working out of RAM, and your good config is always being stored in NVRAM, which is when you save your work because you know it's a good, solid config. So let me change that enable secret again. Enable secret, put it back to class. There we go. And now to actually save a work, this is how we do it. There's syntax, and I want you to type this syntax out. This is not how you type the command, but I want you to type this out right now. It's from privilege exec mode, which is our pound sign. The command is copy, and then here's the syntax. What I mean by that, this is the steps. From space to. When I say syntax, this is the actual how the command works. It's going to be the command of copy. That's the command. After copy, you're going to type where you're copying from. After that, you're going to be copying where you're copying to. So if we have that in mind, I didn't mean to click enter. If we have that in mind for the syntax, now the command will make more sense. We're going to use this command, copy space running -config space startup -config. And that says copy from the running config where we're working right now and put it to startup config. Copy from RAM to NVRAM. And once you hit enter with copy running config space startup -config, it says destination file name startup -config. Whatever is in brackets will be taken automatically when you hit enter. If you type in yes, it's going to try to rename the file to yes, where it is being saved. We do not want the running config to be named yes in our NVRAM location. We just want to hit enter and have it be named startup -config as shown in brackets. It says building config, and now your work is saved. If my box reboots right now, we have lost nothing. It is exactly rebooted at where we're at right now, which is pretty sweet. I like this stuff. You can also save things to a text file. Some people like to do this. They'll do a show run, which is your running config, and they will literally copy and paste the entire output to a text file. And you can do that because this is literally your config. You can just copy the whole thing, put it in a text editor. Just don't put it in anything that has macros like Microsoft Word because you'll get so much extra characters and junk in there. Don't do that. Text editors like Notepad, WordPad, Notepad++, things like that. All right, so closing it all down. Addressing. We are on a switch. True. A switch is considered a layer 2 device. True. Uses MAC addresses and not really IP addresses. True to all of that. But we still want to be able to have remote management of our switch. Because if you have like 30 switches in your network environment, do I really want to have to run around to every floor with a blue console cable coming off of my laptop? Not so much. So how can we remotely manage this box so I can stay in my air-conditioned, cool office, my little tiki dancing lamp thing, mini fridge, you name it, music playing. What? I don't want to leave that. But I have a Fitbit. Go get steps. No, we want to actually work remotely and easily connect to these devices. So in order to talk on a network, devices need an IP address, a subnet mask, a default gateway. And on your local machine, if you opened a command prompt, which is just start CMD, cat, mouse, dog, start CMD, and you get a command prompt. You can actually just type ipconfig, and don't mind me, I'm just literally changing my font size so you can read it better. There we go. That's much better. Much better. Awesome. So you type ipconfig, and after ipconfig, you just hit enter, and you'll see your IP address. And if you have a domain name, you'll see your subnet mask, you'll see your default gateway. And to talk on a network, a machine needs an IP address, subnet mask, and to talk off of a network, you need a default gateway. So if our switch wants to be remotely reachable, we got to give it an IP address, a subnet mask, and if our switch wants to talk off of its network, which we can talk about in chapter 11, it needs a default gateway. So we got to give this to the switch. The switch needs info so the switch can be reachable. Now, every single device on a network should have a unique IP address. The switch can't use the same address as my PC. It can't, because then it's not unique and can't be uniquely targeted. So we're going to configure something on the switch. So we need an IP address, but where are we going to put it? Well, on a switch, all the ports, which there's 24 of them, are layer 2. The ports on a switch hook to PCs and they work with MAC addresses. So as we go further into our Cisco studies, specifically in Cisco 2, which is Routing and Switching Essentials, we teach you VLANs. For now, take this with a grain of salt. On the motherboard of the switch are virtual interfaces. We've established that with VTY lines. But on the motherboard of the switch are also these. Global config mode, head into it, do it with me, config T. The ports that exist on the motherboard of the switch are also interface VLAN. VLAN, if you studied Network Plus before, is a virtual segment. It's a virtual network. We have virtual interfaces called VLAN interfaces on our motherboard. By default, every port on a Cisco switch, by default, is in what is called VLAN 1. Every port on your Cisco switch is physically part of VLAN 1. So if we configure an IP address on the virtual interface known as VLAN 1, every single port on our switch, well, can be utilized to send management traffic to the VLAN 1 management interface. Just think of it, motherboard, virtual port called VLAN 1. Every physical port can reach virtual port of VLAN 1. That's how a switch works by default. In Cisco 2, as mentioned, we have a full 2 chapters in Cisco 2 just on VLANs. So we'll get there. So interface VLAN space 1, enter. And now we are configuring a virtual interface known as VLAN 1. And here on this motherboard of the switch, I can use commands like IP space address on this virtual port that can be reached through any physical port on the switch. Cool. IP address we want, let's just get one. How about 192.168.1.1? Space. Now we need to give it a subnet mask. Our computers have a subnet mask. We need one here too. The subnet mask actually defines the size of your network. So all 255s.0, 255.255.255.0. That is called a /24, known as a Class C mask. We'll talk about this more in chapters 6 and 7 when we get to subnetting and talking about IPv4 versus IPv6. For now, we just need an IP address and a mask. When I hit enter, now the IP address of 1.1 has been configured on this interface VLAN 1. Now this thing is actually reachable, except for one command. By default, these virtual interfaces are usually turned off on a switch. To bring a port online, regardless if it's a physical port like a fast Ethernet 1, or if it's a virtual port like a VLAN 1, the command is no space shutdown. Shutdown is one word, but no space shutdown actually brings a port online. And when you type that and hit enter, no space shutdown, you actually get a message. Wait for it. Maybe you don't get a message because maybe on this switch it's already up, which is ironic. In Packet Tracer, I would have got a message. We'll do a show command in just about 2 minutes. No message. Usually it says change state from down to up. Alrighty then. So let's continue onwards and we'll see a message later. I'll show it to you in Packet Tracer or somewhere else. But we have to give our PC an address. That PC over there, we want it to be able to remotely connect to the switch so the PC can use Telnet or SSH and remotely manage the switch. To do it, go ahead and click on your PCA in your lab, run your Java file when you get it, and we'll have a live Windows 7 client running on this network with that real switch. So when you get through the run boxes with that and you click on the PC in Java, you literally will be on your Windows 7 box. With this Windows 7 box, when you get there, bottom right corner, you'll see the networking icon next to the clock. You can right click on it and go to Network and Sharing Center. And Windows 7, we're just doing a static IP, that's all. So right click on the network icon next to the clock, Network Sharing Center. To statically put on an IP address, if you haven't done it before, it's Change Adapter Settings, top left corner. Right click on your NIC card. It's the Intel one, not the Cisco VPN one, but the Intel NIC card. Right click and go to Properties. Inside of your properties of your NIC card, the Intel, click on IPv4 TCP/IP, Properties. And all we have to do is say, you know what, there's no DHCP server here. There's nobody giving you an IP address automatically. Click on Use the Following. With Use the Following, the switch was 192.168.1.1. Will just be 192.168.1.2. You hit Tab, auto fills in the subnet mask. Tab, we don't have a default gateway. There's no router or exit point. Just leave it blank. After you type in your IP address of 192.168.1.2 and hit Tab where it fills in the same subnet mask because it's on the switch, click OK. And the funny thing about Windows 7 is unless you click Close, it doesn't apply it. So click Close and then the IPv4 address is actually applied to the NIC card. Well, how do we know it is? You can click Start on the PCA computer, CMD, cat, mouse, dog, and then ipconfig, and verify on that Windows 7 machine 192.168.1.2. Cool, good to go. Or are we? So how do we know that we can actually remotely manage it? Well, we're actually going to do it. With our IP address on our box, we're going to make sure that we can go out and reach that interface VLAN 1. Here's a slide that says, oh, there's a video available in the online reading, but we did that already. So that's remotely access that thing. And before we remotely access anything, best practice, networking, IT, ping it. If you can't ping it, most likely you can't reach it for things like Telnet or SSH. So ping the target of 192.168.1.1, which is the switch's IP address. If this doesn't work, there's no way we're going to telnet to that thing. So we'll shoot a ping off. It'll send 4 echo requests, and we'll see if we get 4 echo replies back. The first echo request failed. It timed out. It timed out because of ARP. The PC is like, who is 192.168.1.1? I've never heard of this person. What is their MAC address? So while that ARP was going out, the ping was failing. But the ARP came back in under like a tenth of a second, and then the remaining 3 pings actually went through just fine. Reply from with a time 1 millisecond, 2 milliseconds. So now I know I can reach it. So that's telnet to this thing. I don't like telnetting through the command prompt. Let's use Teraterm. Teraterm is on the Windows 7 desktop. It's the yellow laptop with the T. You can double click that. And we'll have TCP IP selected saying we're going to use a protocol on the network. We're going to click Telnet as the radial button. Then for the host, we will type in the target, 192.168.1.1. It shows us Telnet is selected. We're using port 23, and we're targeting 192.168.1.1. Once you click OK, click, look at that. We're sitting on a PC. This PC could be 30 switches away. 30 switches away. It would have been the exact same setup. Nothing would have been different here. Password. This is the VTY line password. It was the same password as console. It was Cisco. You type Cisco, enter. You're now in user mode. Enable. Then we get further into this box. Password. This was the enable secret of class. Enter. And now we're live in our privileged exec mode. We're on the physical switch. Well, we never really got to have too much fun with this thing yet, so might as well have fun with it now. What if we did something crazy? There's a command that I want you to know called show version. Show version is literally you're like right-clicking on computer on Windows 7 and clicking on properties and saying, hey, look, there's my RAM. There's the operating system I'm running. Look, if I go deeper, I see my hard drive. That's what this is like. Type show version and click enter. When you type show version and click enter, this is literally your specs on your box. And you spacebar it all the way down. You'll see, if you space it all the way to the bottom, hey look, it says my switch is a WS Cisco, which is C3560 24TS. It's the 24 port switch, it's the TS model. The version we're running, the exact operating system is a C3560 operating system running IP services K9. K9 does not mean puppy. K9 means supports encryption, cryptographic key sets. This operating system should never be exported outside of the United States because it supports the United States cryptographic key sets. All that stuff with government, DoD, whatever. So if we wanted to scroll upwards, we could. And scrolling upwards, we see more info regarding our box. Hey, look at that. Non-volatile config memory. What does that mean? That's NVRAM. How much of it do we have? 512 kilobytes. Like, oh my goodness, is this from like 1992? No, that's the startup config. We're talking text file. Remember our show run? Our show run was 1.4 kilobytes. That's what our show run was. I think that fits just fine in a 500K location. Up above, if you scrolled up further, you'd be able to see your ports, 24 fast Ethernet ports, and there's 2 gigabit ports on this switch. If you scroll up even further, we'll see, hey, look, we have a Power PC405 CPU on our switch, and the switch has 132 megs of RAM. I don't think that's right. I'll have to double check that. I think that's flash. I'll have to take a look at that. I still think that's flash. It might be, but it shouldn't be RAM. RAM is usually like 64. 256. But anyways, I'm talking to myself. I'm sorry. So if we scroll up higher, we again see our operating system, which is on our box. There it is again, the same as you saw before. And what this is like saying, it's like saying we're running Windows 7 here. Windows 7 version 1 Service Pack 2. The way to read this actually is we're running iOS 15 release 2 Service 9. And it's like, okay, you're running iOS 15 and Service Pack 2 and then build 9 of Service Pack 2. And as they actually increment their builds, it's because they're fixing errors or releasing new features, usually fixing errors. So you download, oh, I still have iOS 15.0, but I'm on release 3, which has these error fixes, or release 4, and just little patches to it. That's all. But the show version is your bread and butter command to actually see what you're running. I still think that memory is going to be RAM. I didn't see the flash. The flash is usually your hard drive in Cisco. I didn't see flash in here. No, it's not a hard drive of 512K. That's your NVRAM. So I'll find it in here somewhere. But yeah, it's cool. It's the gist of it. You can do show flash, and show flash actually shows you your hard drive. And that's what's in our hard drive. So yeah, kind of cool. And there's my operating system. It's right there. As we close up, lastly, there's a, I didn't show you this show command. I'll show you that, and then we'll close up. And then we'll just ping, which we did to make sure it works before you tell them that and all that jazz. But let me show you another show command. Show you a show. And while we're on the switch, to verify interfaces that are up, the command is awesome. It's show IP interface brief. And I'm going to do it on the console of the switch. The only reason I'm doing it somewhere else than you is because I want to have the larger font. And that's all. You can do it from your Windows 7 virtual. But show IP interface brief. This is an awesome summarization command. It lists every port on the switch, and you can spacebar to get the full text, but it lists every port on the switch and their status. Virtual interface VLAN1 is shown here. Has an IP address. It is physically up, logically up. Why 2? You can be physically up and logically down. That's usually an error condition. You could be administratively down. You could be up and up. You can be down and down. The reason people are usually down and down is because there's a cable unplugged. Administratively down means someone has used the shutdown command. No matter what you do, that port is physically off. That's administratively down. Someone used the shutdown command on that port. Right now, I have a huge list. Again, there's 24 physical ports on this switch and 2 gigabit. I don't want to see all this. I don't care. What I want is this awesome command to show you right now that'll help you through the rest of your Cisco studies in every Cisco class. Show whatever you want. For me, IP interface brief. But don't hit enter. There is something called the pipe command. If you look at your keyboard, right above the enter key, there's a vertical line, just a straight vertical line. It's the same key that has a backslash. If you do shift pipe, you get a straight vertical line. It looks like an I, but it's not. It's a pipe. So I just show IP interface brief, space, pipe, space. Check this out. Include up. This pipe command is a filter. It's a modifier. I can say I want the show IP interface brief output, but I only want to see what's included that is up. And you hit enter. Look at that. That is sweet. We see the same output as before, which would have been 26 interfaces, 27 if you include VLAN 1, and now I see 4, because it only shows me the stuff that has a status of up. And check it out. What else could we do? You can question mark it, but you can do exclude. How about we exclude up? Show me everything that's down. What's not working right now that probably should be? Exclude up. Give me everything that's down. Okay. How about include down? Well, it would have done the same thing. Include stuff that's down is the same as excluding that's up. But you can do this with show run. You can do this with show IP interface brief. You can even do it with other commands that are much more detailed, which include show interface, where you get huge paragraphs of output. You can filter using those pipes commands. With those pipe commands that we mentioned here, there's tons of different options available. We have append, we have begin with a specific part of the output. I don't want to see 3 paragraphs worth. How about we begin the output with the input queue? We begin the output with a gateway message. You can choose that. The only way you really learn this is by playing with it. Start getting comfy with your show commands as you read through the material. Get comfy with the show commands as we take a look at our outputs, and you can start filtering for exactly what you want to look at, which is kind of sweet. Again, some additional stuff for your studies and to play with. But again, Packet Tracer, really basic. Packet Tracer can't support some of these show outputs we're doing right now, including the piping. So you got to practice on the real equipment as much as you can. With that being said, that's the end of today. That's the end of chapter 2. So make sure you actually go through, play with the labs, and become an all-star, rock star Cisco person.